basic constraints. We learned some constraints, right? In the previous topic, we learned, integrity constraints, a few simplest constraints. Yeah. Now let's study a few more constraints. Yeah. The first one, define a primary key. Yeah. So here we need to study the primary key. Yeah. In the previous topic, we learned a few properties of primary key, but here we need to learn some more aspects about the primary key. Yeah. Use the primary key clause. How to define a primary key? Yeah. There are a few ways. The first way, the simplest way, using that primary key clause directly after a column, right after that column. Yeah, very convenient. Yeah. So the primary key clause specifies one or more attribute. Yeah. Here, two cases. The simplest case is only one attribute is used as the primary key. The simplest, single attribute primary key. Yeah. Then we can append that primary key clause right after that column attribute. Yeah. But there is another special situation, more than one, two or more. Yeah. So I will explain this two or more case later. Yeah. Why people use two or more attributes to define a primary key. Yeah. All right. Yeah. First, let's look at the single attribute case. If a primary key can be defined by a single attribute, we want to use single attribute to define primary key. Yeah. Then the clause can follow the attribute directly. Yeah. Like this example. D number, department number. So in our department table, yeah. So I already posted that company database. Yeah. So you look at the structure in the script. In the department table, there is a D number column. Then data type, integer. Then we want to use this attribute as the primary key of this table. Yeah. So you use that constraint directly. Simplest way to define primary key. Yeah. All right. Then another form of the primary key clause. Yeah. So this is the first way. Yeah, very simple. But there is another way. Yeah. Slightly different. Yeah. We use primary clause in this way. Yeah. What's that? Yeah. Single multi. Okay? Yeah. Single. The second way can be used for single and multiple column types primary key. Yeah. Single way. Yeah. Single attribute primary key. Yeah. So here we start a new row, new line. Yeah. So in the table, so you list all the all the columns, right? You define all the columns. Then you write this clause, primary key clause, parenthesis, inside parenthesis, the column name. Yeah. So this way, yeah, you define a single attribute primary key. Yeah. Let us use the department table as the example. Department table, you list all the columns, yeah, line by line. Yeah. At the end, you put this clause. Yeah. After you list all the columns, then you write this primary key clause, parenthesis D number. Here you only put a single attribute inside parenthesis, so that's a single attribute primary key. All right. Then composite primary key. Yeah. I will explain why people sometimes they need to use composite primary key. All right, later. Let's look at how to define composite primary key. Simple. Yeah, we use this way, but composite, that means multiple attributes are needed to define one primary key. Together, simply, you just put primary key. So this is another table. So this one, this is the dependent table. Yeah. So this example, this is because, oh, sorry. Yeah, I need to write here. Yeah. There is a dependent table. Inside dependent table, yeah, how to define a primary key? Yeah. ESSN, employee social security number. Yeah. One column. There is another column called department underscore name. Yeah. So here we need to use two attributes together as a tuple, parenthesis, comma separated. Yeah, so this we can treat it as a tuple, yeah, to define a composite primary key. The way is simple. Yeah. Now let me explain why we need to use the composite primary key. Yeah. Let us still use this dependent table as example. Oh, sorry, I need to write here. Yeah. Dependent table as example. For the dependent table, think about this question. We know the purpose of the primary key is used to identify the different roles, right? Yeah. So the reason people use the primary key, yeah, because they want to identify all the rows in this table. Yeah. All right. So let's look at the dependent table. Yeah. Because the structure is simple, so here I do not show you that structures. Yeah. In the dependent table, first, each dependent needs to be associated with the employee. Okay? Employee. So that's why there is this ESSN column. Okay? So this dependent is associated to that employee. Yeah. But one employee may have multiple dependents, right? Yeah. Spouse, sons, and daughters. Yeah. Could be multiple sons, multiple daughters, right? Yeah. As dependents. That means each employee, as each ESSN, may appear in this table multiple times. It's not unique. That means ESSN cannot be used as a primary key. Not unique. Okay? Yeah. Then, dependent name cannot be unique, right? Because name could be repeated. That name is first name. Yeah. You know, first name of different dependent could be the same. Yeah. So each of these two columns is not unique. The value is not unique. So none of them can be used as the primary key, right? Yeah. But the good thing is, if you combine them, if you use these two columns together, then the value is unique. Yeah? Because think about, when you use the first column, employee, SSN is fixed. Under that employee, the dependent name must be unique, right? Yeah. Dependent, same family, you know, different dependents should use different names. Yeah. Then, when you use these two values, then this two value tuple, yeah. So we treat it as a two component tuple. Okay, the value is unique. Then it satisfies the requirement of primary key, unique values. So we can use this way, composite primary key, to define a primary key for that dependent table. Okay? Yeah. So similar idea. Yeah. If 2 columns not enough, then people may consider three columns, right, to make it unique. Yeah. Things like that. Yeah. Yeah. But so here, let me give you a little more description on the primary key. Yeah. Although primary key is convenient, yeah, we can identify different rows, but there is a possibility the primary key of a table may not exist. There is a possibility. That means for the whole table, even if you use multiple columns, you can never define a value of the primary key. That's possible. Why? When that table is a multiset. When a table is a multiset, that means 2 rows could have exactly the same value, component by component, from beginning to duplicate. There are 2 duplicate rows. When you have 2 duplicate, how can you define a primary key? Because 2 duplicate rows cannot be identified, right, by any number of values. Any number of values in that row. You can never identify, separate 2 duplicate rows. Yeah. So in that situation, primary key can never be created for that table. Yeah. Yeah. It's okay. No primary key. In that situation, no primary key. Yeah. Yeah. All right. Yeah. That's the. All right. Then there is another way to other than these 2 ways, there is a third way, use the alter table statement. Yeah. Actually, in the example I show you in our company, yeah, I export the database script, then I give it to you. You can see this third way. Alter table way. You use this statement. Alter table name. Then you add a primary key clause. Yeah. Then you use this, the format the same as this second way. Yeah. 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 So that's the alter table way. Yeah. Yeah. Later, after the table is created, you can still add the primary key in this way. Yeah. All right. Yeah. So that composite. So you need to understand the special case. Although in the real world applications, the possibility to use composite primary key relatively low. Yeah, but it could happen. It could happen. Yeah. So you need to consider that case. All right. Then key. Key, yeah. So no primary key, yeah, it's a key. Okay? Yeah. Key has some more properties we need to study. Yeah. One special property similar to that primary key. Yeah, we will see. All right? Yeah. Unique clause. Yeah. Yeah. So we used that before. Yeah, here there are several ways we can use the unique clause. The first way, unique clause specify alternate. This is secondary keys. Other than primary key, we may have multiple secondary keys. So we just call keys. Okay. All right. Yeah. If you ask me why, yeah, people, you may ask. Yeah, people may ask why. Why use secondary keys? Right. Primary key we know identify the rows. Right. Yeah. How about secondary keys? Yeah. Yeah. So here, let me give you some why. Okay. one important usage for the key columns. One important usage key column for fast search operation. Fast data search. Think about, if a column is a key, then later in our module 5, we will learn fast data search algorithm based on key columns. We have a key columns because values are unique. When the values are unique, there is a special property. You can sort this table based on this column, right? In ascending order. Value unique. There is no duplicate values. All the values unique. So after you sort it, you can use binary search to find any value. Using binary search, we know binary search very fast. So you can apply binary search based algorithm to do fast search. So that's a very important usage of the key columns. In our module 5, we will learn algorithms. All right. Then use unique clause to define keys. The unique clause can also be specified directly for a secondary key if the secondary is a single. Similar to the primary key. The format. We just change primary key clause to unique clause. Example, single attribute key. After this attribute declaration, we use the unique clause directly. Just like that single attribute primary key. That's the first way. Second way, add after because we can add it later, right? Because similar to that primary key, after we declare all the attributes, then we add this clause. Then composite. There is a situation similar to the situation for the primary key. Because if you use one column, there is a possibility none of the columns, think about it, there is a special table. Let's consider a special situation. Suppose in a table, we have multiple columns. All right. If you look at a single column, if you look at each of the single column, the values, none of them is unique. That's possible, right? So none of single. Oh, I cannot write. Single column. None, all right, none is unique. That could happen. In that situation, you can consider more than one column. You may select two of the columns and see if the tuple using those two columns. Look at the values if they are unique. Or three, more than one. Composite key. You can consider composite key. You may, if you want to ask why people use composite, just as I gave you the reason here, if you can use composite key based on that composite key because the value is unique, You can do binary search, right? Yeah. You can sort. You can sort. And the values of all, based on that key, the values of all the rows are unique. Unique. When you do binary search, no confusion, right? Yeah. So you can, always find. Because for the duplicate values, the algorithm must be modified. If it's another key, okay? If it's another key, you can still do sorting, right? You can still do sorting. Yeah, even not unique, you can do sorting. But when you apply binary search, because there is a range, when you have a value, you do binary search, so your value could fall into a certain range. Yeah. Then how to handle that range? You need to modify your algorithm. You cannot just simply apply binary search. Okay? You need to do more than binary search, because there is a range. Okay? Duplicate values. Yeah. So that the algorithm exists, but you need to modify. Okay? You need to do more work. Yeah. Yeah. That's the difference. So it's more convenient. We do binary search on key columns. Yeah. Yeah. Simpler. Yeah. All right. Yeah. Composite key after unique clause, parenthesis, comma separated multiple fields. Yeah. Yeah. Similar to the primary key way. Yeah. Then alter table way, we can also use the similar alter table way. Yeah. All right. This way. Yeah. Okay. So that's the key. Yeah. Yeah. All right. Yeah. Basic properties. Constraint not null and the default value. Yeah. So we saw this in the previous stuff, but I didn't explain in the previous topic. Yeah. Here I need to explain this constraint not null and the default value. Yeah. It's very easy to understand. Constraint not null. Yeah. Some columns you do not allow null values. Yeah. For some special business reasons, you do not allow null values. Okay. So you need to use this constraint not null. Okay. All right. Yeah. So where an attribute does not allow null value. Yeah. Yeah. Because for some special columns, if you allow null values, then you delay the problem, right? Yeah. Because when you see null value, that means some unknown, unsolved problems you cannot answer at the data entry time, but you need to get it resolved later. Yeah, that's the typical reason to use the null value. But for some columns, it's very important. Yeah, there are some special reasons. If you do not provide specific value, people don't want to delay that problem. You have to solve it at the data entry time. Okay? Don't delay. Yeah, because there is some important reason. You cannot delay it. Yeah. If you do not provide the value, this entry, data entry, is rejected by the DBMS. Must be rejected. So you have to, get it resolved at the entry time. Okay? Yeah. Sometimes you need to do that. Then you need to use this not null clause constraint. Yeah. All right. Explicit. Yeah. So for some attribute, yeah. So you just put this constraint. Yeah. Yeah. At the end. Yeah. Implicit, yeah. This is explicit way. But there is an implicit way, yeah. Because for primary key, we do not need to. Yeah. Primary key, we already assume it must be not null by default. Yeah. So you do not need to add this constraint, redundant. No. No. But for primary key. Yeah. For key, yeah, you need to do it. Yeah. For key, yeah, because primary key, yeah, at the data entry time, you have to get it resolved. The primary key of this row must be provided at the data entry time. Yeah. Otherwise, this data entry cannot be accepted by the DBMS. Yeah, yeah, that sounds reasonable. Yeah, yeah. Default value. Yeah. Then, because if you think about the situation, if you have to use the not null constraint for a particular column, you make it very strict, right? If the value is unknown, if the value is not provided, then you reject it. Yeah. That means a lot of work has to be done before the data entry could be successful, right? Yeah. So people try to reduce that amount of work. Yeah. In that way, too much work, right? People need to do too much work. Yeah. So then, there is one option that allows you to do less work. Yeah. So if the value is not provided, if you have some default value, yeah, so you define default value, then just use the default value. If there is some reasonable default value that could be acceptable for this particular column, yeah, use that. Then you do not need to, do any work to get it resolved. Yeah. So you have this option. Yeah. Appending the clause, default clause, you provide default value after default keyword. Yeah. The default value is used in any new tuple if an explicit value is not provided for that attribute. Yeah. For that attribute with not null constraint. Default value. Yeah. Okay. Yeah. So that could make the data entry a little easier. Yeah. Okay. Yeah. All right. If no default clause is specified, yeah, then without not null constraint, it takes null value. Yeah. So yeah, you can use not null. You can use the null if not null value is acceptable. Yeah, you just use it. Yeah. But with not null constraint, insertion failure. Yeah. Yeah. So you require this column must be not null, but you do not provide default value. Then the only way this data entry must be rejected. You have to get this value resolved before you can do a successful insertion. That's simple. Okay? Yeah. All right. Yeah. Just based on the natural logic. Yeah. So you can easily understand, how to use not null constraint together with default value. Yeah. All right. So that's the part C. Yeah. Now we move to part D. Yeah. Because in our home assignment number 2, we need to do 10 query questions, 10 basic query questions. Yeah. So that's in part D. Yeah. So part D we talk about some special query operations. Then we will practice in our homework assignment number 2. Yeah. So part D. Yeah, 3D. Okay, yeah. Data retrieval by select statements. Yeah. We did some, in the homework assignment number 1, we did some simple select statements. Yeah. But in this part D, we will do a little harder type. Yeah. Yeah. What we did before is a single table select statements. But in this part D, we will do a multi-table select statement. Yeah. Join multiple tables. Yeah. Most of the time, two. Yeah. Sometimes, in some rare cases, it could be three. Three table join. Yeah. But most of the time, two table join. Yeah. All right. Let's study the theory. D.1, basic form of select statement. Yeah. Select from where block, the basic structure. Yeah. 3 clauses. So select part, from part, where part. Yeah. All right. Yeah. In the select part, you need to provide a list of attributes. In the from part, a list of tables. Yeah. Multiple tables. Yeah. Okay. Where part, condition. Yeah. Condition, it should be a Boolean expression, right? True or false? Yeah. Boolean expression. True or false, unknown, right? 3 value Boolean, 3 SQL Boolean values. Yeah. But only true. Only the row that generates true value is selected. Yeah. False, unknown, not selected. Yeah. All right. Then projection attribute. Yeah. Here, there is a concept called projection. Projection on this list of attribute list, projection attribute. Here, let me explain this concept. Yeah. So when people talk about projection, so you know what they are talking about. Yeah. Here we use the geometry concept, projection from geometry, right? Yeah. So you have a line segment, you can do projection. Yeah. Here. This is the ground level, okay? Yeah. Ground level. Yeah. Then you have a pole with some certain angle, okay? Certain angle, the pole. Then the sunlight is in this direction. Sunlight. So then you do projection of this line segment. Yeah. So this part, this is the projection in geometry. The projection concept in geometry. Here we borrow the concept from geometry, yeah, but we don't have line segment. Okay, we don't have a line segment, but we have some object that looks similar to line segment. Object looks similar, so we use the analogy way to understand this concept. Yeah. So what object is similar to line segment concept? Attribute list. Yeah. So here, yeah, let me use attribute list, but what attribute list? Yeah. So let me write this one, okay? In the original table definition, you need to define a list of attributes, right? You need to define a whole list of attributes in the original table. So that's our, all the attributes included in this table. Right? So that one, okay? Yeah. There is an attribute list. Yeah. This list contains all the attributes in this table, right? Yeah, yeah. So, yeah, by our definition, table. So this, because this one contains all the attributes, so we use this list as this original line segment. Yeah, everything is there. Okay, line segment. Okay, full length of the line segment. So that's the analogy. Okay, we do the analogy in understanding. Yeah. Then, when you do projection, the line segment projected usually is shorter than the original line segment, right? Yeah. When you do projection, the projected line segment usually is shorter than the original line segment, right? Shorter. All right. Yeah. Here we use this projected line segment to refer to attribute list in your select statement. Because in your select statement, you select some of the attributes, right? Part of the original attributes, not the full. Yeah, you can select the full, but sometimes people don't need all the attributes, right? Many times people only need some of the attributes. Yeah, part of it. So we call that part of it projection. Projection, okay? Yeah. That's the understanding of this concept. Yeah. Okay? Yeah. Could be full, yeah. Full case is a special case. Yeah. But most of the time you don't need all the attributes. You just need some of them. Yeah. So it's a projection. Yeah. This kind of understanding of the projection. All right. Because later I may give you a question in your homework assignment number 2, also in your midterm. I give you a table with certain number of attributes. Then I ask you, you need to tell me, you need to count how many projections. Yeah. Okay? 3 attribute projection, 2 attribute projection, how many? Okay? So you need to understand this concept. What is a valid projection? Okay? What is a valid projection? Yeah. Yeah. Here, let me give a simple example. When you count, so here, when you count number of projections, the order matters. The order matters. What's the meaning? Okay? So let me use two value projection. Okay? 2 attribute projection. Yeah. A1, A2 projection is different from A2, A1 projection. Okay? Yeah. Yeah. For 3 values, you have the similar case. A1, A2, A3, different from A3, A1, A2. Okay? The order is important in each projection. Okay? Yeah. Based on definition. Yeah. So then you need to tell me how many different projections you can find given certain number of attributes. Yeah. For example, if I tell you in this table there are 4 attributes, total 4 attributes. Okay? Yeah. Then I ask you to tell me how many projections containing 3 attributes. How about that? 3. 3 out of 4. 3 attributes. The order is important when you count. Order is important. Yeah. Okay. Yeah. Yeah. All right. The select clause specifies the attributes whose values are to be retrieved. Yeah. But usually, some of the attributes in the original table. Yeah. All right. Then, selection condition. Yeah. This where clause. Selection condition. Yeah. Where clause. The where clause specifies the Boolean condition that must be true for any tuple. Okay, so here must be true. Yeah. Because we know three-value logic, right? Because we know in SQL, we use three-value logic. We need to keep this property in our mind. Yeah. For example, if I say in this way, okay, if I modify this sentence in a different way, ask you true or false, I say like this. The where clause specifies the Boolean condition. Let me say in a different way, because I want to say a statement, and I ask you this statement is true or false. Yeah. I say in this way. When we do a select statement, yeah, in the where clause, if the Boolean value of this where clause does not return the false value, then the row is selected, true or false. If I tell you, the where condition, its Boolean value is not false. I say not false. Then I say this row is selected as in the query result. Selected in the query result, true or false. I say not false. Here I change. What do I change? I change from this true value to not false value. True. I change true to not false. I modify it. True or false? I make this change. Remember three-value logic. You need to use this three-value logic property. If it's not false, could be true, could be unknown, right? There is unknown there. So there is a possibility it returns unknown. Can you select it? You cannot. Because only true value, you can select it. If unknown, you cannot select it. Okay? So that statement is false. Yeah. So you need to use the three-value logic to answer your questions. Okay? Do not use our usual two-value logic. If it's not false, that must be true. Here it's not. If it's not false, you have an unknown case you need to consider. Yeah. So that will impact your answers. Many questions, such questions, you need to be very careful. Yeah. All right. Oh, I forgot to do one thing. Yeah, because I didn't set a timer. Yeah, so I may. Yeah, let me set timer now. Yeah, otherwise I may. So now we have 20 minutes. 20 minutes. Yeah, let me set 20 minutes. Okay. Yeah. All right. Yeah. Otherwise, I may, use too much time. All right. retrieval, select statement. Yeah. Result returned. Yeah. It's a multi-set of tuples. Yeah. Return result is a multi-set of tuples. So it tells us we allow duplicate rows. We allow duplicate rows. Yeah. Yeah. Because many business requirements need duplicate rows. Yeah. Yeah. So do not remove the duplicates in the result unless the business requirement does not need duplicates. Yeah, that could happen. Yeah, sometimes we need to exclude those duplicate rows. Yeah, so then you have a special way to remove the duplicates. Yeah, all right. Duplicate tuples can appear more than once. Yeah. Reasons not eliminating duplicate tuples. Yeah. The user may want to see duplicate tuples in the result of a query. Yeah. Especially in a situation. Yeah. Later we will study aggregate functions. Sometimes we need to, apply aggregate functions. Then duplicate rows, we need to keep those duplicate rows when we apply aggregate functions. Okay? Sum, yeah, we take sum, yeah, you don't want to eliminate duplicate values. Average, when you take average, you don't want to remove duplicate values. Yeah. Yeah. Duplicate elimination is an expensive operation. Yeah. But sometimes our business requirement needs distinct values. Yeah. When that happens, you need to explicitly remove the duplicate. Yeah. You need to apply some special operation to remove. Yeah. Although there is a convenient way to do it. But to do it, yeah, relatively, yeah, so expensive. So here I just say relatively expensive operations. Yeah. There is a cost. Yeah. There is a cost in response time. Yeah. So it's not free. Yeah. It takes some time. Yeah. You think about given an array containing duplicate values, how do you remove duplicate values in an array? Yeah. You can write an algorithm to do it, right? Yeah. Yeah. So one commonly used way is you need to sort. Yeah. You sort the array, then you remove duplicate very easy, right? Yeah. Yeah. Because all the duplicate values are back to back, okay. Yeah. Together. Yeah. So you take the first one. After the first one, if you get a sequence of values, the same as the first one, then you remove them. Yeah. So sorting, but the sorting operation is quite expensive. Sorting, yeah, takes quite some time. Yeah. When the table is relatively large. So now you think about, there is a cost. Response time, relatively slow if you want to do that. Yeah. So this tells us, if you know this property, so this one tells us, based on this property, we should avoid unnecessary duplicate removal. Okay? Yeah, what's that? Yeah. Because later you will see we need to do many select statement type queries. Yeah. All right. Sometimes we need to remove duplicates. Sometimes we do not need to remove duplicates. Okay? Yeah. So you have options. Yeah. You have options. Yeah. Sometimes, because we can get the same result. So you think about this. Yeah. You know, some intermediate table. Intermediate. Yeah. We need to work on some intermediate table. Some intermediate table contain some duplicate rows. Yeah. Yeah. The question. Yeah. But do we need to remove those duplicate rows, or we keep duplicate rows? Yeah. When you need to make your decision on this question, you need to look at the final result. If removing the duplicate rows, if it does not change the final result, removal or not removal, two possibilities, the final result the same, then you don't remove. Okay? Yeah, because our goal, final result, right? Final result is the most important. Yeah, yeah, because for some special situation, yeah, removal or not removal, you get the same final result. Why you remove it? Because even when you spend more time, yeah, sorting, you know, it takes a lot of time. But the final result the same. Why you do it? Yeah. So this probably tells us you can make your query statement faster by, you know, doing things in the right way. Yeah. Based on the property. Yeah. Yeah. Because when we write SQL statements, performance is very important. Yeah. So you want to write a fast SQL query, right? You don't want to write a very slow SQL query. Yeah. So in this class, we will learn how to write in the right way to get fastest possible result. Yeah. Search result. Yeah. All right. One way to implement, yeah, sort tuples first and then eliminate duplicates. Here I say one way. That means there is other ways, right? Yeah. So one way, one simple way. Yeah. 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 One possible way. Yeah. Sorting. Yeah. But there is another way. We can remove duplicates without sorting. Remove duplicates without sorting. We know sorting is expensive. If you can do the same thing, removing duplicates without sorting, that looks good, right? Yeah. So here, there is a special search technique. Yeah. A faster than sorting way. Faster than sorting way. Apply. Yeah. If you learn the algorithm class, hashing. Using this hashing technique. You do not do sorting. You create a hash table. Okay? Yeah. So hashing technique. Okay? Yeah. Yeah. So the hashing technique, but you need to build a hash table, right? Yeah. You need to build a hash table. Yeah. To build a hash table, the complexity for building hash table, big O of n, number of data items, big O of n, okay, yeah. Linear. Yeah. Then, after you build hash table, yeah, yeah. Because when you build hash table, at the same time you can remove duplicates. Yeah. When you build, you can remove the duplicates at the same time. Why? Because when you have a duplicate, you have a collision, right? You compare the value the same, collision, so you don't insert. If the row happens to have the same value already in your hash table, you reject it, right? You throw away. You do not need to insert in your hash table. Duplicate values, why you insert, right? So you throw away. So when you build, At the same time, you remove duplicates. Yeah. But building hash table, the complexity is bigger of n. Okay? Yeah. That means you can remove duplicates by bigger of n hashing method. Okay? Then sorting. How fast is sorting? What is the complexity of sorting? Okay? Yeah. If you do sorting, the complexity, yeah, the fastest possible complexity, big O of n log n. N log n slower than n, right? N times log n. Slower, yeah, significantly slower than n, right? So your sorting way is slower than the hashing way. Okay? Yeah. Especially when you have large tables. Huh? So you like to use the hashing way. For small tables, then, yeah, because the constructing a hash table, the overhead are relatively large. Yeah. You need to, you may have some overhead, okay? Yeah. So but when you have a large table, then it's worth it. Yeah. So you spend some resource on the overhead part, it's worth it. Yeah. Yeah. It is worth it. Oh, yeah. Worth the cost, extra cost. Yeah. 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 All right. Then, but in SQL, we just use this distinct keyword in the select statement. We just use distinct keyword. Then duplicates are removed. Yeah. We don't know inside DBMS how it is removed. Yeah. 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 We know DBMS uses the fastest possible way to remove. Yeah. So we don't worry. We just apply this statement. Yeah. So we can remove duplicates. Yeah. When an aggregate function is applied to tuples, in most cases, we do not want to eliminate duplicates. Yeah? Because you want to cover all the rows when you apply aggregate functions. Yeah. Okay? Yeah. Yeah, but here, I want to, yeah, for this special case, I want to raise one question I mentioned before. Yeah. Because aggregate functions, there are many aggregate functions, right? Yeah. Average is 1. AVG, average is 1. Sum, another. Count, yeah, you count the number of rows. Count. Yeah. Maximum, minimum, max, and minimum. Okay? Maximum and minimum. Yeah. All right. Yeah. Yeah, but here, yeah, let me use this max function. Finding the maximum in this table with respect to one particular column. Finding the maximum. Okay, all right. When we find a maximum, the values in this column could have duplicate values, right? Yeah. Could have duplicate values. Multiple rows in this particular column, they have the same values. But it's okay. We apply the max function on it. We find the largest one. So the question, do you want to remove the duplicates, then apply the max function, or just apply the max function directly? Yeah. Same result, right? Yeah. So it's unnecessary to remove duplicates, right? Yeah. We apply max function on the table containing duplicate values without removing duplicate values. It will be faster. If we remove first, then apply, it will be slower, right? Yeah. Because you need to spend some time to remove duplicates. Yeah. But the max, without removing, yeah, do it directly. You can save some time. Yeah. So that's what I mean. Yeah. Sometimes removing or not removing, you get same result. Why you need to remove the duplicates? So that's an example. Yeah. That's the max function. That's example. Yeah. All right. D.2, remove duplicate tuples. Yeah. That's syntax, pretty straightforward. Yeah. Just add distinct keyword. Yeah. All right. Example. Yeah. So here, yeah. Yeah. So when you put a distinct before this list of attributes here too. Yeah. ESN, comma 6. Yeah. Then, what's the meaning of distinct? Yeah. So here you need to understand what's the meaning of distinct here. Yeah. Is it you apply distinct on the first column or combination of the two columns, right? Combination of two columns. Yeah. Actually, you apply distinct on the combination of the two columns. In that sense, distinct. Okay, not on the first column. Yeah. On both. It covers all of the attributes in the list. That distinct. All right? Yeah. Yeah. So that's the result. Okay? Yeah. The duplicates, yeah. So if, yeah. So here, for example, if one employee has 2 sons or 2 daughters, yeah. Yeah. Okay? Yeah. Same sex, under the same employee, same sex, then only keep one. Okay? Only keep one, yeah, yeah. So, in that way, yeah. So for the same employee, so this, SSN, same employee, you can only have one F, one N, okay. Yeah. Unique values, yeah. That's the combination of 2 columns, yeah, yeah, yeah. Also, spouse also included, yeah, because dependent table contains the spouse information, yeah, included, yeah. All right. Then, D.3, join 2 tables. Yeah. Today we do not have much time. So this is the most important topic of this part, join 2 tables. Yeah. Yeah. All right. We will learn next time, yeah, but let me see if we need to do some simple preparation in order to understand this whole topic. Yeah. All right. So here we start with one simple question. Yeah. Then we need to study the theory. The theory, how to join 2 tables. Here the question. Retrieve the name and address of all employees who work for research department. Yeah. Who work for the research department. Here you can see, yeah, so if we use our company database, yeah, in order to get this query statement, our data, we need to know our data comes from what tables? We need to find all the tables that we need to provide the data for this query. Yeah. All right. The first table we need, yeah, because the name and address, that information, you need an employee table. The first table. Okay. All right. Then you also need research department, so you need a department table. So your data comes from these 2 tables. Yeah. So you need to use the data from these 2 tables. Yeah. The question is, so when you need to use mixed data from these 2 tables, how to organize the data in these 2 tables so that you do not mess up. Okay? Yeah, because it could be very messy, right? It could be very messy. Yeah. All right. Sorry. Yeah. So we need to stop right here. Yeah. So next class we will study how to organize the data in two different tables in a nice way so that we won't mess up. Okay? So we can always, follow some well-organized way to select our data. Yeah, the theoretical part, theoretical understanding of table join. Yeah. All right. Yeah.